A radio frequency signal received and amplified by a cell phone exhibits a peak swing of 10 millivolts. That is, the peak to peak amplitude is 10 millivolts. The peak amplitude of any one half cycle is 5 millivolts, that is 0.005 volts. We wish to generate a DC voltage representing the signal amplitude. Is it possible to use the half wave or full wave rectifiers to rectify this? No. The reason is the peak to peak amplitude of the input swing. Half wave rectifiers causes one diode drop of the input signal and presents at the output, that too only positive half cycle. Full wave rectifier presents both positive and negative half cycles, also flips the negative half cycle but with two diodes drop. That is, if input voltage peak is V0, output voltage peak will be V0 minus 2 VD on. Owing to its small amplitude, the signal cannot turn actual diodes on and off, resulting in a zero output. For such signal levels, precision rectifiers are used. So if you see, the one diode drop is 0.3 volts for germanium based diode and 0.7 volts for a silicon based diode. If input signal exceeds one diode drop, say 0.7 volts for a silicon based diode, then only the diode will be on, then only input can pass to the output, the two with one diode drop. But here the peak to peak swing is itself 10 millivolts, or one peak signal voltage value is only 5 millivolts, that is 0.005 volts, which is far less than 0.7 volt, which is the minimum input signal amplitude required to turn on the diode. In case of full wave rectifiers, 2 diode drops is the minimum signal required to turn on the 2 series diodes. So in full wave rectifier, minimum 1.4 volt amplitude of input signal is required to turn on the diodes, and a minimum of 0.7 volts of input signal swing is input peak value is required for the input signal to turn on the diode for a half wave rectifier. But here it is only 0.005 volts. So the diodes will never turn on, so output will always be 0. So in this case we have to use precision rectifiers which have very low diode drop. We cannot use the ordinary normal half wave rectifier or full wave bridge rectifier circuits.